Hey guys, welcome back to another video, and today we're going to be solving the Leet code question, add two numbers. Alright, so in this question, we're going to be given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. So in simple words, we're going to be given two different linked lists, and each of the linked lists ends up representing a single number. We want to add them, and then we want to output a linked list of the added sum. So you may assume that the two numbers do not contain any leading zeros except for the number 0 itself, okay? So you wouldn't have something like 0, 1. If anything, you would just have the number 0. Perfect. So one thing you do want to realize is the fact that it says reverse order. So what exactly does it mean when it says reverse order? So in this case, we have 2 pointing to 4, 4 pointing to 3. Now in this case, if you just look at it, you might think the number is 243. But remember that it is stored in reverse order. And since it is stored in reverse order, over here, the values that we're going to end up getting is going to be 342. So this over here is at the hundredths place, this over here is at the tenths, and this over here is at the unit place. So 342. Now this actually makes it a lot easier for us to add the numbers. Now before we actually go through how we can solve it, in the beginning you might think all you need to do is just add its corresponding value in the other number. For example, 2 and 5, so you just add it up, get 7. Now over here, the problem is once you get 6 and 4, you actually end up with the value of 10. So you can't store the value of 10 over here. You can only store a single digit. So what actually ends up happening in such a case? So in this case, like as it is with normal addition, you're going to have a carry forward. And the carry forward is going to be the number 1. So in other words, the 1 is going to get carried forward over here. So in this case, we would have 3 plus 4, which equals to 7, plus 1, because the 1 is the carry on. So it's pretty simple, and let's just see how we can do this real quickly. So this is the exact same example, and all I'm going to do is write the numbers. So 243 is the number 342, and the reason for that, like I said earlier, is because it's in reverse order. And this 564 is the number 465. Now, one thing you do want to realize is that these two could be of different lengths. They do not necessarily have to be of the same length. All right, perfect. So when we add these two numbers, what do we get? So we get 5 plus 2, which is 7. Pretty simple. Now over here, we get 6 plus 4, 10. So in this case, as it is with simple addition, what is the value that ends up going over here? So we get 6 plus 4 equals 10. But what is the value that goes over here? Now the value that goes over here is whatever is at the units place. So it's pretty simple. So whatever is at the units place, which in this case is the number 0, and everything else gets carried on. So in this case, the number 1 gets carried on. Now what you want to do is we're not just adding the values of the number 1 and number 2. We're also going to take care of our carry on. So in this case, it would be 4 plus 3 plus 1, giving us a value of 807. And all we need to do is we want to convert this into a linked list. So this would be 708 because we want it in reversed order. Okay, perfect. Now, so in this case, you can kind of understand that the formula of addition is going to be the value at number 1, the value at number 2, plus whatever the carry on is. So what we're going to assume is that when we do not have a carry on, the carry on is going to have a default value of the value 0. So in this case, in the beginning, our carry on is going to be 0. So it will be 5 plus 2 plus 0. So in this case, we get the value of 7, and 7 is less than 10. So we don't have any carry on. So the carry on for this as well is going to be 0. So 6 plus 4, which is 10, and then 0. And in this case, we do have a carry on of the value 1. So we need to account for it. So that's why we add it at the very ending. So the idea of this should be pretty simple. And let's just real quickly see how it actually works in terms of a linked list, okay? So in this case, the first value we're going to get is 2 and 5. So we're going to add them. So you can just kind of assume as 2 pointers over here. So the first pointer is at 2 and then at 5. So we're going to add it and we get the value 7. We're going to create a new linked list node with the value 7. So this for here is a new object of the linked list class. Perfect. So now we move both of our pointers to the right by 1. So this moves to the right by 1 and this moves to the right by 1 as well. Perfect. So now we have 4 and 6, and this gives us the value of 10. Now in this case, remember, we're going to have a carry on value, and this is just going to be a variable which starts off at a value 0. So in this case, we have the value 10. So to our linked list, we're only going to be appending whatever is at the units place. So 7 is going to only point to 0. And the carry on in this case is now going to get updated. And the carry on, so the actual value is 10. So the carry on is going to be whatever value we get divided by 10, right? So it's everything except for what we have in the units place. And we're going to be doing integer division in this case. Okay, perfect. So in this case, 10 divided by 10 gives us a value of 1. So the carry on is now going to have a value of 1 over here. Now in this case, we move our pointers again to the right. So now we have 4 and 3. So now we're going to end up with the value of 7, but we need to account for the carry on, which is 1. So this would now end up becoming 8, giving us the value of 7 pointing to 0, pointing to 8. But in this case, so technically, so then we go to the next value, and how it will look like is in a linked list, the 3, since it's the ending, it's now going to point to none, and this is also going to point to none. Okay, and now when you move the pointers, they're both going to be at none, and in that case, since both of them do not have a value, we're going to stop our iterations. Now, one thing you do want to notice is they could be of different lengths. So in that case, what we're going to do, let's say there's an extra value over here, then we're only going to move the pointer for whichever has a value existing, and for the other value, we're just going to assume a value of 0. Okay, so this over here works out pretty well, but we also want to look at one more condition where we might have a small problem, or we just need to account for it, right? So let's say we're doing 4. So this is the linked list, right? So 4 is actually a node, and we also have the second linked list is the node 6. That's it, 4 plus 6. Pretty simple, right? So when you add it, you get a value of 10. But how exactly do you account for this in our question or the way we're solving it? So it's pretty simple, but let me just show you where we actually end up lacking. So we have the 2 pointers, the same place, and the carry on just starts off with the value of 0, right, in the very beginning. Now in this case, you have 4 and 6, and now when you add them up, you get a value of 10. So in that case, you just take the units, whatever value you have at the units place, which is 0. Which is 0, and that is going to be part of our linked list. Now, in this case, 1 is now going to be the carry on. So let's write it on. So the carry on is now 1. Okay, so now in this case, what's going to end up happening is we're going to move our pointer. So remember, 4 points to none, and simultaneously, 6 is also going to point to none. Now, in this case, like I showed you earlier, once both of them reach a value which does not exist, so in other words, when both of our pointers reach the very ending, we're going to stop our iterations. We don't really need to do anything else. And that's what happens. Over here, we're stopping, and this ends up becoming our answer, which is wrong. The answer should actually be 10, but this over here is just the value 0. So what exactly do we have to consider? So the consideration that we need to make at this point is once we reach none for both the numbers, so this number and this number, when we reach the ending for both of them, and even at the ending, if there is some value at our carry on, right, like we have in this case, then that means that that has to be added. So in simple words, we have 6 and 4, and all we're doing is we're only accounting for how many places there are. So in this case, we're only going to be accounting for one place because 6 has one place and 4 has one place. So we only account for the 0, but we're not accounting for the 1 and 10, right? So we're not accounting for the full value, which is 10. So the 10 over here is an extra space that we need to account for. And to do that, what we're going to do is if there's a carry on over here, we're directly going to add that as a new node. So to see how that looks like, we had the value 0. And to this, its next value is now going to be whatever is at our carry on, which is 1. And this right here gives us a value of 10 since it's in reverse order. And that's the correct answer. All right, so for looking at the code, one thing that we're going to have over here is going to be a dummy head. So the dummy head, you can think of it as just as a space holder, right? And I'll show you how this is going to work like. It's pretty simple. So in this case, we're creating a new node with the value 0. But at the very beginning, we don't know what that value is going to be, right? So, or in this case, right, we're creating a new node with the value 7. But at the very beginning, we don't know what that value is going to be. So to kind of account for that, we're going to have a dummy node, okay? I'll just call it D. And this dummy node is nothing else but a placeholder. We're going to define it at the very beginning, and all it does is just there so that we can attach other values to it. So in this case, for example, what we would do is to our dummy value, we're going to start off at there for the sum, and the 0, which we get here, is going to be pointing, so the dummy node is going to point to the 0. And the same thing goes over here. So the dummy node is going to be pointing to the 7 for this when we are doing these two over there, right? So the whole purpose of this is just as a placeholder, and at the very ending, what we're going to end up returning is whatever is to the next of the dummy node. So in this case, that would be the number 0, and in this case, it would be the number 7, and whatever is after that. Okay, so it's a pretty simple concept to understand, but yeah, that's what we're using. And you could give it a value of 0, you could give it a value of none, or whatever. Okay, and now we're going to have our carry, and the carry, like I said, is going to start off with a value of 0. Now we're going to have a pointer. Now the pointer over here is going to be for the sum list node. Okay, so let's just call it current. And where is it going to start off from? So current is going to start off from our dummy head over here. So that's exactly where it's going to be. So current is going to be equal to our dummy head. And now you might be asking, what about the pointers for the first number, the second number? So for that, we're just going to directly use these values over here. So L1 is going to be the pointer for the first linked list, and L2 is going to be the pointer for the second linked list. Now we're going to go inside of a while loop. And in our while loop, we're going to keep going as long as L1 or L2 has a value, right? So as long as either of them has a value, we're going to keep going. And and you want to notice that we're doing OR, right? So at one point, one of them could not have a value. So we do need to account for that. So because we're accounting for the fact that something could not have a value at one point, we need to check if L1 has some sort of value at that point. So if L1 has a value, then in that case, we're going to have a new variable called L1 underscore val. And this is going to be equal to the value in L1. And if you're confused about where I'm getting .val from, over here we have a class which is predefined for us. Okay, so this class is predefined for us, and it has the attributes value, which equals to its value, and next, which equals to whatever it's pointing to. Okay, so that's exactly where I'm getting these .val and .next from. Okay, so now L1 underscore val is going to hold that value. And if this is not the case, that means that L1 does not have a value. And in that case, L1 underscore val, which is right over here, is going to be given a value of 0. And the reason for that is, so if this is not the case, we would assume that there's some sort of value in L2. So in this case, when you end up doing L2 plus L1, all you're doing is L2 plus 0. So it just has the value of L2. So that's all we're doing over here. Now again, all we're going to do right now is we're going to copy this and do the exact same thing for L2 over here. Okay, so we're going to check if L2 exists. Then we're going to check, then we're going to have a variable called L2 value, and that has to be equal to L2.val, else L2 underscore value is going to be equal to 0. Okay, so that's going to be it. Should be pretty simple. Okay, so now over here, we're going to have our sum variable. So let's just call it sum underscore, and that is going to be equal to our L1 value. So L1 underscore value plus the L2 value plus the carry on, right? And again, in the very beginning, the carry has a value of 0, and that makes sense because in the units place, you cannot have a carry which is not equal to 0. So that should be it for this over here. And now once we're over here, we need to form our linked list. So to do that, we're going to do current.next, and current.next over here is going to be equal to whatever is at the units place of this value. And to do that, actually, one more thing we want to do is we want to make it an object of our list node class. So to do that, we're going to do list node. And what exactly do we need to give it? We need to give it the value. In this case, the value is going to be equal to sum underscore mod 10. Okay, so whatever is just at the units place. So that's going to be it for that. And now we need to do two things. So one of them is to update our current pointer. And all we're doing is current is now going to be equal to current.next, since we're going to move it to the right by one space. And now the other thing we need to do is update our carry. Now the carry in this case is going to be equal to our sum divided by 10. Now one thing you want to notice is this over here is going to give us a floating point value. So just to kind of, so to fix that problem, we're going to be doing integer division. So pretty simple. So the same way how we updated our current pointer, we're also going to be updating the pointers inside of the list node 1 and list node 2. So to do that, what we're going to do is we're first going to check whether we are already at the ending. So if we're at the ending, we're not going to do anything else. So to do that, we're going to do if L1. So that means that if L1 has some sort of value, and it means that we're not at the ending yet. And in that case, we're going to move it to the right. So L1 is equal to L1.next. Now simultaneously, we're going to do if L2, and we're going to be doing the same thing. So L2 is equal to L2.next. And that should be it for our while loop. And at the very ending, there was one other condition that I showed you about, and we need to account for that right now. And that simple condition is if we still have a value in our carry. So in this case, if our carry has some sort of value, what we're going to do is we're first going to convert it into a list node object. So list node, and it's going to have a value of the carry itself. And this over here is going to be current.next. So current.next is going to be pointing to this value over here. And that should be it. So at the very ending, we just need to return a value. And what we're going to end up returning is going to be dummy head.next. Okay? And that's going to end up returning the actual head that we have. And if you submit this, this should get accepted. Okay, so as you can see, our submission did get accepted. So finally, thanks a lot for watching, guys. Do let me know if you have any questions. And don't forget to like and subscribe. Thank you.